use my usual USB mic, which has reasonable quality. All right, so this should be recording right now because it's, the volume is flicking, so that's good. And now we can go back to the file that I just downloaded, which is a zip file, which contains some documents, from that particular exam. Oh, I guess you can do it that way. The user command line to do it. Oh, where did I put it? Temp folder. I can't remember where I saved the file. Oh, I guess it decompressed it already, so we have all these files. Exam, 1.0 title, 1.1a, 1.1b, and so on. So those are the questions, but those are the exam 1 questions. So we're looking at exam 2. Okay, let me check when did I put it. Open containing folder. Okay, it is inside Mozilla _user 0. Okay, there we go. Okay, so we go to temp, Mozilla user 0, and there's the file. In Windows, you just open it up, because Windows know how to open the zip file. I'm using Linux, so it's a little bit different. Okay. So when you decompress, it will give you all these individual files. X2 stands for exam 2, Q1 is question 1, and some questions have multiple versions. So I usually just kind of mix and match, I even I won't know which combination of questions the person is going to get. Okay, so but they're all pretty much equivalent. So we just have to take a look at one and not all of the other ones. The exam is going to be the same format as the first one. It's open book, open notes. No electronic tools during the exam. You can bring anything that is either handwritten or printed prior to the test. So that means, it also includes like screenshots, okay? If you go through the video stuff and you say, okay, this screen is particularly helpful, freeze the screen, print it out, bring it with you, okay? But you cannot watch the YouTube stuff, during the test. But you might, think that that's ridiculous. I actually had people doing that in the past. Sorry? Yeah, I actually had people doing that. It's open book, open notes, but they have to actually, it's a practical test, which means they actually have to turn in code that runs, okay? So they're using on the computer. Then I go like, well, okay, might as well just open YouTube as well. And I saw people, watching YouTube while they're trying to answer the questions. Not very effective, I have to say. I've also seen people selecting the entire question text, right-click, and search Google search for that. And most of the time, it will give you an answer, but not what I'm asking. All right, so getting back to this one, I'm going to start with question number 1. Okay, so we'll take a look at cisp300 x2 q1, just q1a.pdf. And this is the question. I give people this one that only has arrays but not subroutines. So it's going to be about the same scope for this class, because we talked about arrays already. So we'll take a look at this one. Is that good enough? We can see the code. Yep, we do. All right. So that's the code that people have to trace for this particular exam, and the array elements are already initialized. So if we scroll to the other side, you can see that the array is initialized, but it is going to be initialized based on your student ID. So that's why there's only one version of question number 1, because based on your student ID, the behavior of your code and the trace of your code is not going to be different from every other student. So everybody gets a different trace in this case. But grading it is not really much more difficult than the previous exam, because what I do is I actually write a script So I plug in your student ID and I can see exactly what the answer is supposed to be. Then I can just do a visual match between your trace and the output of my script. That makes it easier. Okay. All right. So let's take a look at this one and we'll work it out. Okay. And let's see. This is the code. Okay, so what I'm going to do is I will actually do this inside a spreadsheet so we can actually capture the trace. So we'll start a spreadsheet here. And just start with the random one. I'm not going to capture the algorithm itself in the spreadsheet. There's no need. It's already here. What I do want to capture is the trace or the columns. So I want to replicate this part into the spreadsheet. All right, so we have columns. That's a pretty high-pitched one. X, Y, Z, I. And then we have array A. Array A has 7 elements because we have 7 digits in our ID. So 0, 1, 2, 3, 4, 5, 6. There we go. All right, so we don't need to look at this part of the PDF document anymore. Let's go ahead and switch back to the code itself. And I just want to show the minimum portion, so this way I can maximize the area on the other side to show the trace. All right, so M all the way to A. Just minimize everything until I need more space to do the trace. Comments probably need a little more space. Okay, so I'm going to use a fake ID here. If it does accidentally match your student ID, don't worry because it's not intentional. You just don't want to let people know that that's my student ID. Okay, so I'm going to use 1, 4, 2, 9, 0, 6, 5. Okay, there we go. I don't know whether it does match a student ID in this class or not, but it looks like a real student ID to me.
Yeah, close to
Really?
Yeah.
Okay. It's just random. Okay, so we'll start the execution of this program. The precondition is going to be specified here. Everything is going to be uninitialized except for the array itself. And then we get started with the code. Line 1 is initializing I to 0. Line 2 is initializing X to 0. Line 3 is initializing Y to 0. And then line 4 is initializing Z to 0. So these 4 lines, I would probably not even have point values associated with these because they're not really that important, okay? So if someone just runs out of time and can only finish the algorithm up to this point, there's no point, okay? I'm not gonna give that person any points because it's not, there's no demonstration of any understanding of concepts of arrays, which is what I really want to test. So starting on line 5, we do have something that relates to arrays because we are comparing I, which is just a normal variable, with bar A bar minus 1. Now bar A bar is telling us how many elements we have in the array. In this case, we have 7. But 7 minus 1 is 6. In other words, I'm comparing I to 6. I is less than 6 is true because I is 0 at this point. So we say this is true. And then we move on to line 5 as the result of line 5 having a condition that is true. Line 6 is the evaluation of A bracket I is less than A bracket I plus 1. So this part depends a lot on your actual student ID. In this particular case, I is 0, so I plus 1 is 1. I'm comparing A bracket 0, which has a value of 1, with A bracket 1, which has a value of 4. 1 is less than 4 is true. So the condition of line 6 is true, which means we go into the then branch corresponding to that condition on line 7. Line 7 is going to increase x by 1. X goes from 0 to 1. Then we are done with the entire multi-branch conditional statement. So we continue on the line that is after and if. So we continue on to line 13. Line 13 is incrementing I by 2, not by 1. So I is going from 0 to 2 here. Then we have to go back to the beginning of the loop to check the condition again on line 5. I is now 2. 2 is less than 6 is true. So now we go for another iteration starting with line 6. Line 6 this time is comparing a bracket I and I is 2 with a bracket I plus 1, which is 3. So we want to compare a bracket 2 versus a bracket 3. In this case, a bracket 2 has a value of 2, a bracket 3 has a value of 9, which means the result of the comparison is once again true because 2 is less than 9. So we continue on to line 7 again, and we add 1 to x. X goes from 1 to 2. And then we get out of the conditional statement. We continue on to line 13. We add 2 to I again. I goes from 2 to 4. And then we continue on to the beginning of the loop on line 5. We re-evaluate I is less than bar a bar minus 1. I is now 4, bar a bar minus 4, bar a bar minus 1 is always 6. So it is still true. And we move on to line 6. And because I'm doing this with a spreadsheet, it is possible to split the screen so we can see the heading of each column as we scroll through the actual body of the spreadsheet. On line 6, we are evaluating the condition a bracket I is less than a bracket I plus 1. So we have to first take a look at the value of I. I has a value of 4 at this point, so we are comparing a bracket 4 versus a bracket 5. Unfortunately, the value of the array is hidden, so I can just move this down a little bit so this way we can see the actual value in the array. A bracket 4, once again, is less than a bracket 5 because the values of those two elements are 0 and 6 respectively. 0 is less than 6, so that's why, once again, it is true. We go to line 7 again. We add another 1 to x. X goes from 2 to 3. We get out of the conditional statement. We continue on line 13. We add 2 to I. I goes from 4 to 6. Then we go back to line 5 again. I is now 6. Bar a bar minus 1 is also 6. 6 is less than 6 is false. We get out of the loop. We get to post. We're all done. Okay. So the actual behavior of this code, like the values of x, y, and z, and how you get through the multi-branch conditional statement, depends a lot on your actual student ID. So with this particular example, this is the result. Are we okay with this? Are there any questions regarding this particular question? No questions? Okay. All right. So if there are no questions about this, I am going to start a new sheet and close. Well, I guess I can use this to open another exam question. Let's see if I can do that. New window. Not that. Annotate. How do I open another document? There we go. Open. And we want to go to the 10 folder over here. And we want to open up the second question. The second question has multiple versions. So I'm going to open up just the first one. And this is the actual code. And let's close this. And oops, magnify. There we go, 150%. That's good. All right. So I'll put the code on one end here, and then we'll have space to trace it. So this is a fairly simple program, but it does have a combination of things that we have seen along the way to this point of this class. First of all, it has got mod. 2, it has got array concepts, because there's the mod bar a bar, and then the a square bracket. And last of all, the easiest part is it has a post checking loop, which we have introduced in the second week of the entire semester. Okay. All right. So we'll take a look at the behavior of this code. We have comments as one column, line number as another column. We have I as an independent variable, and then we got a as an array. In this case, a is already initialized. So we have to basically follow the same thing. So A bracket, okay, I need to figure out the way so that we can see both at the same time. Okay, we can probably do this. Okay, so this is array A, it has got 5 elements, 2, 3, 4, oh, at least 1. Cannot count. And 4, yep, okay. We just have to put the values here, 57, 47, 7, 37, and 17. So now we can go ahead and shrink the columns as much as we can so they can show on one screen. And that's it. Okay, now we can trace the algorithm. The precondition is the array itself is initialized, but the variable I is not initialized. Then we continue on to the first line, which is line 1. I gets initialized to 0. Line 2, we don't trace because the word repeat doesn't do anything. Okay. Line 3 is the real mystery line. Okay, what is it going to do? Well, you just have to do it in the right order. You have to do whatever is the innermost pair of parentheses. In this case, we only have one pair, so we do that first. I has a value of 0. Oh, I forgot to trace line 1. No, I did. Okay, never mind. So I has a value of 0 at this point, and A bracket I is the value of A bracket 0. That has a value of 57. So we are adding 0 to 57. And then we want to find the remainder of 57 divided by bar A bar. Bar A bar is referring to the number of elements in the array, which is 5. So we are trying to compute 57 divided by 5, and we just want to find the remainder. So before people pull their calculators out, let's try to do this by hand first. Okay? 57 divided by 5, what is the remainder of that division? 2. Yep. Okay, we don't really need a calculator for that sort of thing. Okay. So 2 is now stored back into I, and then we go to line 4. Line 4 is comparing I to 0. I equals to 0 is false because I now has a value of 2. So we go back to line 3 again. So we go back to line 3, and this time we are adding 2 to A bracket 2. A bracket 2 has a value of 7. So we're adding 2 to 7, which will give us 9. 9 mod 5 is the remainder of 9 divided by 5, which is going to be 4. So we restore 4 into I. So if someone look at this and go like, oh, there's no way I can get back to 0 and just terminate the trace and say, okay, this is an infinite loop, that person will get partial credit, because this loop will exit. Okay, we'll see how it's going to exit. On line 4, I equals to 0 is false because I has a value of 4, not 0. Then we go back to line 3 again. So this time we have to add 4 to A bracket 4. A bracket 4 has a value of 17. 4 plus 17 is 21. And what is the remainder of 21 divided by 5? 1. That is correct. So we store that 1 into I again. And then we go to line 4. We ask the question, is the value of I 0? The answer is no, it is false. We go back to line 3 again. So this time we add 1 to A bracket 1. A bracket 1 has a value of 47, which means the total is 48. 48 mod 5 is the remainder of 48 divided by 5, which is 3. Okay, so I is now 3. Go back to line 4. I equals to 0 is still false. Then we go back to line 3. Now, why can't I conclude that this is an infinite loop? At this point, if I have to use one reason to say that we should not stop right now, yep, go ahead.
You've tested the values for 0, 1, 2, 3, 4.
Yep.
Well, you're just doing 3 now.
I'm just, it's
You
just
said
3 right now.
0, 1, 2, and 4. You haven't done 3.
But I haven't seen a repeating pattern yet. That's why it cannot stop. Yep, go ahead.
There's an array slot with the same remainder that's needed to add into a multiple file.
Yep. But I cannot stop because I haven't seen a repetition of the pattern. Now, if I start to see like 2, 4, 2, 4, 2, 4, then there's a good reason to stop because it doesn't seem like you can get out of that pattern. If I see 2, 4, 1, 2, 4, 1, 2, 4, 1, then I can probably conclude, okay, this is most likely going to be an infinite loop. Even if I say 2, 4, 1, 3, and then 2, 4, 1, 3 again, or just 2, 4, 1, 3, and then a 2, that's probably a good reason to stop. Because once you get back to 2, it's going to repeat the same pattern again. Okay, but I haven't seen the repeating of the pattern yet. So that's why there's no good reason to stop at this point, concluding this is an infinite loop. All right, so we get back to line 3. This time we are adding 3 to a bracket 3. 3 is a bracket 3 has a value of 37. 3 plus 37 is 40. The remainder of 40 divided by 5 is 0. So we put a 0 here, not here, here. Then we proceed to line 4, and I equals to 0 is now finally true. And because this is a repeat until loop, when the condition is true, we get out of the loop and get to post. And that's the end of this trace. Are there any questions about this particular trace? Now, I do use mod, which is a concept that we introduced before exam 1. So it's not intentionally comprehensive, but I think stuff and concepts that we have talked about before can still needs to be understood at this time. Okay, it's not like U.S. history where you can have exams blocked by time periods. Okay, sorry.
Load up, bring down, load up, bring back.
Yep.
Can't bring back.
But in programming, you can't do that. Okay, I cannot say, well, the concept of variables was introduced before exam 1, so we're not going to use variables in exam 2. Well, if I don't use variables, there's no point in asking anything. I cannot do a single thing without variables or assignment statements or loops and stuff like that. So it is not intentionally comprehensive, but we cannot say, okay, topics from before exam 1 cannot be in exam 2. I cannot do that. Okay, so you still have to study for all the materials from before. Okay, so this is the second question. Let's take a look at the third one. Okay, so we use this to open, and we take a look at the third one. There are 3, 4, 5 rare variations of the third one, but they're all pretty close. Okay, close this and zoom in to 150%. This is the code that we want to trace. Oops, let's close this one. So when it opens a new one, it actually opens a new window. It doesn't just replace the old one. So once again, this one just makes use of the array concept. There are no subroutines in here. It also has a mod, and it has 2 arrays instead of 1. Other than that, there are no real tricky, it has a loop in a loop too. So you have to understand and remember how to do with nested loops. But other than that, there's nothing really too special about this one. So with this one, we also want to take a look at how the arrays are initialized. So over here, we have the initial condition. And to do this trace, I'm going to copy everything into the spreadsheet. There's another way to do this, but I think it's going to be even more time consuming than copying everything into the spreadsheet first. I can actually annotate on a spreadsheet, but that's going to take actually more time than doing it the other way. So I'm just going to replicate everything here. So we got comments, line number, NIK array A. It's got 4 elements, 2, 3, and the initial values are 2, 3, 5, and 7. And then we have array B, which also has 4 elements, bracket 0, bracket 1, 2, and 3. and those are all unknown to begin with. There we go. So now it's time to shrink all the columns except for comments. And also the 45 is the initial value of n. I and k have unknown initial values. Okay, question mark, and another question mark here. That's the precondition. So now I have replicated the initial condition. Now we can go ahead and trace the rest of the program. Here we go. There. All right.
Wrong.
Did I?
Wrong sheet.
Oh, wrong sheet. Okay. Let's close it. And get back to.
No.
Yep. There we go. All right, this is question number 3. Okay, line 1, really easy. K gets a value of 0. Line 2, I gets a value of 0. Line 3, we're comparing n to 1. N is greater than 1 is true, because n has a value of 45 at this point. Go to line 4. Line 4 starts to get a little bit more difficult, because now we have to look at a bracket I. I is 0 at this point. A bracket I is a bracket 0, which has a value of 2. So we are looking at n mod 2 in this case. N is 45, and the division of 45 divided by 2 has a remainder of 1, and 1 equals to 0 is false. Okay, so the entire expression is false. You just say the same thing, n mod a bracket I equals to 0 is false. So I'll leave a little more space here so we can see the entire thing. So where do I go when line 4 has a condition that is false to begin with? Line 9 is correct, okay, because line 9 is right after the inner loop. So because of the way we nest the control structure, the next line to execute is line 9, which is just adding 1 to I. I is now 1. Then we go back to line 4 again, because line 9 is the end of the outer loop. So we have to continue on the first line of the outer loop, which is line 4. Still line 3. And it asks n is greater than 1. It is still true. We haven't done a single thing to n. It is still 45. And then we get to line 4 again. Line 4 is going to ask, what is n mod a bracket I? Is that 0? Okay? Well, but this time I is 1. A bracket 1 has a value of 3. And 45 divided by 3 has a remainder of 0. Okay? So that means the condition is true, because we are asking whether n mod a bracket I is 0 or not. The answer is it is true this time, which means we have to go into the inner loop. So we go to line 5. Line 5 is saying, okay, b bracket k is getting the value of a bracket I. It looks and sounds kind of complicated, but if you work on this one step at a time, it's no big deal, because we work on the right-hand side first. The right-hand side is just a bracket I. What is I? I is 1. So a bracket I refers to a bracket 1, which has a value of 3. So the entire right-hand side just evaluates to 3. The left-hand side on line 5 is b bracket k. K has a value of 0, so it's really just b bracket 0. B bracket 0 is column J, which is the column that we're updating. Okay, so we go to column J, and we say, okay, let's update this column to 3. And then after line 5, we get to line 6. Line 6 is just adding 1 to k. K goes from 0 to 1. And then we go to line 7. Line 7 is a division. It's dividing n by a bracket I. So here's the question that really should be irrelevant. Are we only keeping the integer, the whole number portion of the division, or are we going to keep the whole thing? Why is it not even a relevant question? Because we already know that a bracket I is a factor of n. So the result of the division is going to be a whole number anyway, so there's no need to do any truncation, there's no need to specify that, okay? All right, 45 divided by 3 is 15. So we store 15 into n is now updated to 15. And then we go to, and then where do we go? We are now at the end of a loop, but there are 2 loops here. So where are we going back to? Line 4, because we're in the inner loop. At the end of the inner loop, we have to go back to the beginning of the inner loop itself, which is on line 4. Line 4 is asking, do we have another factor of 3 in n? Because we are asking the same question, n mod a bracket I, is that 0 or not? But you cannot just kind of say, yep, there is, because last time the answer was true. Because we have changed n already, so you have to check again. N is now 15, 15 mod 3 turns out to be 0 as well. So the answer is true, but it's not because the previous time it is true and this time it is true also. It's because 15 is also a multiple of 3. So it is true one more time. We go to line 5. Line 5 wants to store a bracket I to bk, or b bracket k. A bracket I has not changed because we haven't changed the value of I. But we did change the value of k, so this time b bracket k is referring to b bracket 1, which is column k. So we now update column k to have the value of a bracket I, which is 3. And let me split the screen again so we can keep the header of each column. Just like that. Okay, and then we can move on, we can scroll the bottom part now. And then on line 6, we add 1 to k, so k goes from 1 to 2. And then on line 7, we divide 15 by 3, which has a value of 5. And then we go back to line 4 again. And in this case, is 5 mod a bracket I, which is still 3, does not have a 0. So the answer to that expression is going to be false, which will get us out of the inner loop and will continue execution on line 9, which is adding 1 to I. I goes from 1 to 2. Then we go back to the beginning of the outer loop, because line 9 is the last line of the outer loop. So we now go back to line 3, and we check whether n is greater than 1. The answer is true. It is still greater than 1 because 5 is greater than 1. Then we get into the inner loop on line 4, and we evaluate n mod a bracket I again. But this time I has changed. So a bracket I is a bracket 2, which is mapping to column H, which has a value of 5. N is 5 as well. 5 mod 5 is 0. The remainder of 5 divided by 5 is 0. So the answer is true in this case. We go to line 5, and we store a bracket I, which has a value of 5, to b bracket k, which is referring to column L, because k is 2 at this point. So we store a 5 here. Then we go on to line 6. K gets k plus 1, so we are just incrementing k, so it goes from 2 to 3. We go to line 7, which is dividing n by 5, because a bracket I is a bracket 2, which is 5. 5 divided by 5 is 1. We store a 1 into n. We go back to line 4. N is now 1. Mod 5 equals to 0 is false, because 1 mod anything is 1, except it is 1 mod 1. Then we go to line 9. We add 1 to I. I goes from 2 to 3. We go back to line 3. N is now 1. 1 is greater than 1 is false. We are all done. You get out of the loop, which is where we find post. Do we have any questions about this trace? Because it certainly is kind of a combination of some of the concepts that we have talked about. Yep.
I have one question about arrays.
Mm-hmm.
Could you start an array at a number other than 0 or 1 as long as the following number is in order?
Could you repeat that question?
The number right there is 0 in the bracket, right?
Uh-huh. That's the index of a particular element.
Yeah, could the index start at 2 or 3 as long as the numbers are in
Okay,
order?
I see. So the question is, can the first element of an array start with a non-zero? Is that the question? Okay.
Yes.
The answer is it depends on which programming language you're using, okay? In C and C++, and just about any programming language that is based on C and C++, the answer is no. So you have to start the index of the first element in an array with 0. You don't have an option. On the other hand, there are programming languages out there that allows you to specify any number as a start index of an array. Ada comes to mind, ADA, which is a DoD programming language, Department of Defense programming language. But in general, the answer is no. Is that okay?
Yeah.
Okay. So I think that's true in Perl and PHP as well, because both of those are C and C++. They're derivations of C and C++. Okay, so that's question number 3. Let's move on to question number 4. Okay, open again, question number 4, pick out the first one. They're all about the same, even though they're not identical. So we take a look at this program. There are no subroutine questions in this particular exam, but yours will. Rest assured. I may not mix the two together, okay? I may not ask you questions about, oh, here's an array, I'm passing it by reference, what is going to happen, because we haven't really talked about that yet. All right, so we'll finish this one first, okay? So this one, once again, has an array that is already initialized or partially initialized. And we want to find out what this code is going to do to it. Once again, we just have all the usual stuff, and this time I'm throwing floor into the whole thing, okay? Which is something that we talked about before. Floor is the largest number, the largest integer that is less than or equal to whatever is in the parentheses, okay? All right, so let's go ahead and get started with this one, and the first thing we do is to copy the content of the spreadsheet into the spreadsheet itself. Yep.
Doesn't the division already do the same thing as floor?
Yes, when it is an integer division, correct. Okay, so we have comments, line number, and I. We have A. A has 4 elements. Bracket 0, 1, 2, 3. B has 4 elements as well. So we got bracket 0, bracket 1, bracket 2, and bracket 3. There we go. And we'll shrink all the columns. Oh, I forgot to shift click. There we go. The desk surface is very kind of uneven, so it's hard to move the mouse, smoothly. I think it's time to request a gamer mouse pad. Does anyone use a gamer mouse pad at home? Does it make a difference?
Somewhat, not really.
Psychologically, it does.
Yeah.
I used to have a metal one,
Uh-huh.
but it was too small. So I just got like one of those really big ones that like my keyboard's on top of it.
So you don't have to lift your mouse,
Yeah,
when
it's
you're
like- it's
getting
like-
shot at,
it's
right?
like half this table.
Half the table? Okay. So, but then you have to move your arm,
That's because you want to have lower sensitivity, so you're more accurate.
Right.
So you move your arm.
Some gaming mouse has a little button, so you can actually change the resolution on the fly. So when you're in sniping mode, you can turn on the snipe mode.
That's bad. You shouldn't do that.
What do you mean by bad?
Bad habits.
Oh, okay. I use a track point to play some of those games. Do you guys know what is a track point?
Yeah, you just stick it
Yeah.
on the screen.
Yeah, so you have a regular keyboard. So between I think the keys G, H, and B, which are the middle ones, there's a little eraser thing right here, and it's pressure sensitive. If you push it to one side, this thing itself doesn't move, but it will register the pressure and it will move the mouse pointer in that direction proportional to the pressure that you apply to this thing. And I use this, to play the first-person shooting games, and do it fairly well. My kids look at me and go like, "How can you play these games with that little thing in the middle?" Well, it doesn't cause any problems. It just works out just fine. I can strafe, I can do all the other usual stuff. The best user interface for that type of game, I think, is the Wii interface, the Wiimote. Because you have a directional thing, and then you have another you have the nunchuck, so you can use one to control your actual motion and the other one to control the aiming. It's actually very intuitive. I tried to switch from that, playing COD, Call of Duty, and I tried to switch from a Wiimote interface to a PlayStation gamepad. I couldn't do it. It's like, no, it's the wrong direction. Go the other way. And there are people who turn the Wiimote into a inexpensive electronic whiteboard. Do you guys know that? Okay, some people have. Okay, so it's really inexpensive because what you do is you buy a little tripod and then you epoxy a little quarter-inch 20-thread thing onto a Wiimote, or you can just strap it with duct tape or whatnot, and you put it to the side of a regular whiteboard or just a white surface of any kind. Most people do it with a projector, okay? And the way the Wiimote works is it is not really telling the Nintendo game console where you're pointing. All it does is to take a picture of where the IR points are. Okay, and it reports that, I think up to a certain number of points, it reports that back to the Nintendo console, and then the Nintendo console will use that information and go through all kinds of math to compute which direction you're looking at.
The sensor bar is just 2 IR points. You can play with 2 candles if you want.
Yep, except the candles can flicker. That may be an issue. So anyway, it reports back to 2 points. It can track 2 IR sources. So when you use, you can put batteries, a little switch, and an IR-LED or infrared emitting diode into something like this. So you can go to a whiteboard and basically start quote unquote drawing on the whiteboard using IR. The Nintendo Wiimote would actually pick up the reflection of the IR and be able to track it. So what is left to do is really to write the software to talk to your Wiimote to find out where the IR dot is moving. And that is usually done by, it's all done by Bluetooth, because that's how your Wiimote talks to your Nintendo console. So if you know the protocol, which is actually text-based, then you can just write your application to do a very, very inexpensive electronic whiteboard. Because electronic whiteboards usually run at what kind of price? Several thousands, okay? And this time, you just need a tripod, or if you're really cheap, you can just use duct tape and tape it somewhere. And now you have your electronic whiteboard for nothing if you already have Wiimotes. If you don't have Wiimotes already, you go to Craigslist. And you can, by this time, you can probably buy not just the Wiimote, but the entire game console with all the hacked games for maybe what, 35 bucks? Because people are dumping their Nintendo Wiis because nobody wants the Wiis anymore. So now you have your electronic whiteboard and the game console with all the hacked games. And if you haven't played those games before, they're all new to you, just like any other new games. So the best 35 bucks you can spend. People look at me and go like, no, that cannot be the case. Well, I'll prove to you. V mode electronic whiteboard. Okay, this typo, that's okay. And here's the video for that one. This video actually has significance as well. Let me try that. Okay. Why is, oh, that's fine. Okay, you're still not hearing anything.
Only going to use the infrared camera built into the front of each controller.
Okay.
Now this camera is sensitive only to sources of infrared light, which is why it can track things like the
He's my hero, by the way.
Hi, my name is Johnny Lee, and I'm going to show you how to create a cheap electronic whiteboard system using the Nintendo Wii Remote. Now, just like my other video on tracking your fingers using the Wiimote, this project is also only going to use the infrared camera built into the front of each controller. Now this camera is sensitive only to sources of infrared light, which is why it can track things like the Nintendo sensor bar, light bulbs, or candles. So if we want to track pens on an electronic whiteboard, all we have to do is create pens that emit infrared light. The light pen is composed of an infrared LED, a push-button switch, and a connection to a power supply, which could easily be a battery. When I push the button, the LED turns on. This is basically an LED flashlight in a pen form factor. If you want to make one for yourself, you just start off with a shell from a normal ink pen, and then glue in your components. Now behind me is a projected image of my computer. Now if I want to interact with that image with my light pens, I have to make sure that the Wii Remote can always see the tip of the pen. To do this, I have to put the Wiimote off to the side so I don't block its view when I'm in front of the projected image. I've made this little stand for my Wiimote, but you can use any material you have around the house to prop it up in the right orientation. Now when I put it on the shelf, I have to make sure it's pointed at the screen so it can see the whole area. Now it's important to remember that the Wiimote has a field of view of about 45 degrees. So make sure you're back far enough to see the whole screen, but not too far back, because otherwise you'll lose tracking resolution. Once I connect the Wiimote to the computer over Bluetooth, I can do a standard 4-point touch calibration like they do on most electronic whiteboards. What this does is it maps the camera coordinates to the projector coordinates, and now the cursor will show up wherever my pen is, and I can simulate a map.
Okay, I think our IT department has just found that I'm watching YouTube during class time and say, no, Tech, you're not going to do this. But anyway, he is my hero because the same guy is now working at Google. And do you know what he's working on? He's working on, yeah, go ahead. Okay, I thought somebody said.
I'm going to guess whiteboards for inner city schools?
Not really. If you look up, what's his name? Johnny Lee? Okay. So he, Johnny Lee. He's not working for Google, so you just look up his name, Johnny Lee. Okay. And his middle name is Chong. For those of you who play Street Fighter, you probably recognize Chong Lee as one of the characters. But he's not working for Google, and his project at Google is interesting. It's called Tango Lead. It's a very high resolution accelerometer and the software to track it. So it can do dead reckoning. In other words, you just enable that feature on your phone or your mobile device. The resolution is high in both directions. It's both in terms of frequency, like how frequently it can report back changes of forces or acceleration, and also in terms of resolution of per sample. So instead of giving you a really rough, like 6 or 8-bit type of resolution, it can give you a really high resolution. So for someone who just put a device like that without actual GPS or any other way of tracking position, you can run around the block back to the same place, and it will report back that you are now at the same place that you started off with, just by computing, based on acceleration, deceleration, and stuff like that. So he's working on a project like that, which I think is really cool because it is not only cool from the perspective of, oh, now we have a high resolution pedometer, which is not really needed, right? But in terms of robotics, this is actually very useful too, because now you can have robots that can lose track of its own location because of the lack of GPS signal, and GPS can only give you resolution down to a certain really coarse type of resolution. This can give you a much better resolution, especially locally. Okay, so he's working on those projects now, and I have no doubt that Google picked him up partially because of the projects that he did at MIT. Okay, so just so that you guys know get some idea of how you can kind of proceed with your college work and how to transition into real work. So doing projects definitely helps. Okay, so that's a long digression from what we were talking about. Okay, there we go. Is that the one? Yep. Okay. Okay, so I got that. All right. So we have the precondition, unknown value for n. Why am I in the wrong place? Question 4. It is question 4. Okay. So we have 45 for n, question mark for I, 25, 10, 5, 1, and then we got unknown, 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 and unknown. All right. So now we can make this bigger again because we don't need to copy from the other window. And we'll split the screen just like last time. Now we can do the trace. On line 1, I gets initialized to 0. On line 2, we have the condition. This time we need more space for comments because the condition itself is taking a little bit more space. So we have n equals to 0 and I is less than bar, b bar. Okay, so is that true or false? Let's check. I has a value of 0. Oops, n. Okay, n has a value of 45. 45 equals to 0 is false, and we're all done. We just get out. That doesn't make a lot of sense.
Nice.
But I think that's how the question is asked, so.
We take this test?
Maybe that's just like a trick question, is to see if someone doesn't recognize the and or thing.
Or just to see whether people like triple guess and quadruple guess themselves. It's like, no, that cannot be right. Well, that's what it is. Because if the condition is false, it is false. If it's false, we get out of the loop. I think the intention originally maybe saying while n does not equal to 1. Because if you look at the actual code, n divided by a bracket I is being stored in b bracket I, and then n gets n mod a bracket I. So I guess n can eventually be.
As long as you still have more slots left to store.
I think n does not equal to 0, maybe the original intention. So if you turn this one and into n does not equal to 0, that's the original intention. But instead of not equal to, I use it equal to, which means okay, we're done. I think people were really happy about this one that year. Except for the few people who, really quadruple guessed themselves and go like, no, that cannot be the case. And they went through a few iterations anyway, regardless of what the condition is telling them. All right, so that's the actual exam in one of the years. We'll go through another one. There's another one here somewhere. I think this is another one. So we'll click on this one. Once again, it's a zip file. And we'll go ahead and save the file into the temp folder. There we go. And we'll get to the temp folder and decompress it. So this time it really is just in the temp folder. This one is from 2013 spring. And you can see the date is pretty close to, right about now for this year. And once again, we have a bunch of PDF files, and then we have some XOJ files. Those are Zerno files, and I think those are actually the solution to the answers. Okay, all right. And we'll go ahead and close this window. We don't need that anymore. And we'll go ahead and take a look at the questions first. X2, Q1. No, I mistyped it as A1. Oh, I have to go to the folder first. 2013-04-16 underscore cisp300 events cisp300 cisp300 x2 q1a.pdf. Well, that's my Zerno file. I don't want to show you the solution first, so let's show the question first. So it's x2a1.pdf. There we go. This, zoom in. Okay. That's the same as the other one, isn't it? Oh, okay. Oh, there's another one. Okay, this is an ODS, which means we have to use LibreOffice to open it. There we go. So this is the first question. I'm not going to trace this because it's still just asking about arrays. I'm looking for questions that ask about subroutines. So we want maybe question 4. Question 3. Ah. We are on schedule. I just don't have the exams here. We are not behind schedule.
The other years?
The other classes?
Or did you just not have them on
I'm pretty sure I have some that has subroutines. Just give me a moment to find those. Okay, let's sign into apps.lostwheels.de. I might have those, on my Google Drive, so we'll look it up on Google Drive. Okay, so cisp300, spring 16, which is this semester. So if I look up the one in spring 14, that probably is the one that I want to download. Okay, there we go. So let's download. Download anyway. Save. I trust that I have not uploaded something with virus onto my Google Drive.
I think it's like 8 gigabytes or something.
Is it?
Yeah.
Because it also includes the scanned version of all the other ones. Did I actually download it? Yes. Okay, it's still being downloaded. But I can tell you that your question is going to be about the same as the homework assignments. Okay, so it's going to involve subroutine calls, local variables, parameters of 2 types, because we have passing by reference, we have passing by value. Okay, and there will be recursion for sure. We talked about having 2 invocations in the same expression. Okay, so we talked about that. We talked about the return statement. So the return statement is going to be a part of it. So what you do with your homework assignment is reflecting the kind of questions that you can get in exam 2. So from that perspective, it's not really, anything, there won't be anything really that new to the question in the exam. Except, I don't want it to be too wide. There was one year when people actually go to the bookstore and they buy the log for accounting, the general ledger, because they're wider and they're all lined already. Yep.
Will you also be posting solutions to the questions?
You mean the ones that we have already talked about?
Yeah.
Well, those are all being recorded already.
Okay, but like the other questions, the ones that we didn't cover, like there's 3 questions. There's 3, for example.
Well, since we're downloading here, it might take a while. We can we can take a look at those. All right, so we'll take a look at this one first and see if there are any questions about it. So with this one, you can see that I have to have the arrays already initialized. So we have, array A and array B already initialized. And the tricky part about this one is we have a kind of longer expression inside the square brackets on line 4. So let me just kind of focus on line 4 and we'll take a look at this expression. So when you look at the expression inside the square bracket, it is this entire thing. In other words, it's bar A bar, -1, and then minus I. Well, it doesn't really matter how complicated that expression is, as long as it gives us an integer that is within the range of the valid indexes, it's fine. Okay? And the idea of using bar A bar, -1, minus I is when I is 0, then the index for array A is going to be the end of the array. In other words, it's going to be 2. Let's check whether it's 2 or not. Bar A bar is 3. 3 minus 1 is 2. I is 0. 2 minus 0 is 2. So with one array, with array A, it starts from the end. With array B, it starts from the beginning. So I'm really just doing what we call in math, there's a term for this, convolution. With a convolution, you have 2 arrays and you're trying to pick out the first one from the first one, but the last one from the other one, and then you do the cross product, that way. So we are doing a convolution with these 2 arrays. So the end result of this one, or if you want to look at the sum, which is stored in X, is going to be -1 times 3 plus 3 times -2 plus 2 times -2. That's going to be the end result. Is that okay? I'm just kind of quickly and briefly go over these things, just so that to point out what makes this one more tricky than the other ones. All right, so with this one gone, let's take a look at the second one. Save. Okay, this is question number 2. So with question number 2, we also have arrays. And from the code here, let's see if we can figure out what it is really trying to do. W is initialized to true. Do we have a problem with that concept? W is a variable, but it is not storing a number. Well, it doesn't have to store a number. Whatever is on the right-hand side, you can store that. So in this case, W is storing a Boolean value. I is initialized to 0, K is initialized to 2, and then we say while I is less than bar B bar, so you can look at B, it has 2 elements, and I plus K is less than bar A bar, so you can see that array A has 4 elements, and W is true to initialize to true, do the following. Let's look at line 5. Do we have any questions about line 5? Line 5 is an assignment statement. Go ahead. Question.
Sorry, I just don't think I understand. So W has to be true and
W does not have to be true. It's initialized to have a value of true.
okay, so in column W, we just put down true and false rather than
Yeah. Yep, just true or false. Yep. It's just like the found variable in binary search. Yep.
So number 5, the answer is going to be true or false?
Correct. Yep. So that's the whole point, because on line 5, it is an assignment statement. With any assignment statement, you evaluate the right-hand side. Whatever value the right-hand side becomes, you store that to the left-hand side. So let's check out what is on line 5. What is the right-hand side? The right-hand side is this expression here. So that's a conjunction, right? With a conjunction, we just have to make sure that the left-hand side of the conjunction is true or false. The right-hand side is either true or false. One side is W itself, which starts off with a Boolean value. So we don't have a problem with W itself as the left-hand side. The right-hand side is a comparison. We are comparing A bracket I plus K. So in this case, I plus K is the sum itself is used as an index. And we compare that to B bracket I. Well, with any type of comparison, it will come back as either true or false, right? So the entire expression on the right-hand side of the assignment is really just a value that is either true or false. And I take this entire thing, which is true or false, and store that back into W. There's no problem, okay? and then after that we add 1 to I, and we keep doing this until at least one of these three expressions becomes false. That's all this code is going to do. Okay.
So it says while I is less than bracket B bracket and I plus K is less than so and so on and so forth. And
Yep.
W do, what do you mean by and W do? Well, W is true or?
Well, W itself is a Boolean,
Okay.
so whatever it is. So if,
It could be just whatever.
well, when W becomes false, then the entire expression is false.
Okay.
But as long as W is true, it doesn't affect the other expressions, or it doesn't really change the result of the entire conjunction. You just have to remember that W itself is a Boolean variable, so it can store true or false in it. So when you evaluate the condition inside the while, or on the while line, you just have to treat W as one of the things that can either be true or false, based on what value is being stored in W at a time. Is that okay? All right. So this one is actually trying to find a quote-unquote substring inside another one. In other words, it's trying to find whether 1,3 is, which is in B, is also a part of array A, which in this case, turns out to be the case. Okay. Any questions about this particular example? No questions? Okay. All right, so let's go ahead and do this one, and I can just do it in place too because it's already in a spreadsheet. All right, line 1 is W gets true, so we just put it true here. Line 2, I gets 0. Line 3, K gets 2. Line 4, we have to evaluate that long expression. I is 0, bar B bar is 2, which means if I is less than bar B bar, it is true. Let's check out the second condition. I plus K is 2, bar A bar is 4, 2 is less than 4 is also true. So we end up with true and true, so the whole thing is true. We go to line 5. We first evaluate the right-hand side. W is true already, so it doesn't turn the conjunction to false. But we also have to look at the second one. The second one is evaluating A bracket I plus 1 equals to B bracket I. I plus K is 2, so we are looking at A bracket 2, which has a value of 1. I is 0. B bracket I is B bracket 0, which has a value of 1. 1 equals 1 is true, so now we have W being true. The comparison is true as well. True and true is true, so we store true again into W. We move on to line 6. I is now incremented to 1 from 0. We go back to line 4. I is now 1. 1 is less than 2 is true. I is 1, K is 2, the sum is 3. 3 is less than 4 is also true. So true and true is true, so now we move on to line 5 again. On line 5, W is still true, so that is not determining the result of the conjunction. So we have to look at A bracket I plus K equals to B bracket I. I is 1, K is 2, so 1 plus 2 is 3. So A bracket I plus K is A bracket 3, which has a value of 3. I is 1, B bracket I is B bracket 1, which has a value of 3 as well. 3 equals 3 is true, so once again we end up with true and true, so we store true again into W. Then we move on to line 6, we add 1 to I goes from 1 to 2, we go back to line 4, and this time I is less than bar B bar is no longer true, so we say I is less than bar B bar is false, and the rest we don't have to say anything, because in a conjunction, if one expression is false, the entire expression is false already. And because we emphasize the use of short-circuited evaluation, this is what I want you to do. Okay? Don't evaluate the entire thing if you can come to a conclusion by only evaluating the first part. When I say the first part, it's the left-hand side. You always evaluate from left to right. Okay? So when this loop exits, we get out, we say post, we're all done. Yep.
Could you go to question number 4 of this set?
Okay, so we'll take a look at question number 4. This one?
Maybe it was question number 3.
Question number 3. Oh, that's pretty familiar, isn't it?
Yeah.
Except for one thing.
So,
How is it a little bit different from before? Instead of using m plus 1 to put into b and m minus 1 to put into e, it's just m. In other words, in the correct binary search algorithm, line 6 should read b gets m plus 1. And line 8 should read e gets m minus 1. Except in this one, I forgot about the plus 1 or the minus 1. Not accidentally, it's intentional. Okay? So the question is, if I just miss that little detail of plus 1 and minus 1, how is it going to change the way this algorithm is going to work out? Sorry?
It'll make it take longer because you're reevaluating the numbers you've already.
It may
evaluated.
make it take a little bit longer, which is 1 or 2 more comparisons, or it can make it infinitely longer because you never get to the exit condition. Because you can no longer cross over. If an element does not exist, if the value that you're searching for is not in the array, the original algorithm will eventually cross over, because every single time you go through one iteration, B has to decrement by 1 or B has to increment by 1, which means they have to cross over eventually because they're moving in opposite directions. In this case, they're only getting M, which means they can get stuck. Because when B and E are both the same number, then you're stuck because they can no longer get past each other. So that's the whole point of this particular exercise. So when you look at the values that you're supposed to work on, which is down here, okay, we are searching for a value of 6, which is supposed to be found here. And it will probably find it, except the number of steps to find it will be different. But tracing this one is not really that much different from tracing the binary search one, because the only difference is, once again, on line 6 and also on line 8, I did not have the extra plus 1 and the extra minus 1 on line 6 and line 8. So I don't think this one is going to be too much of a problem, as long as you can figure out the binary search one. Is that okay?
Line 11.
Line 11?
Yeah, not E is greater than E.
Yeah.
Because I'm storing as true or false.
It is once again storing a true or false into W. We have found in the actual binary search algorithm, this is just using W instead of found. Sorry?
As it left be in here, you would just do line 10 repeatedly. Once it gets stuck.
Once it's stuck.
Yeah.
Once it is stuck, it will stop between line 4 and line 10, correct? Well, it will be line 4, line 5, line 7, and then line 10. Well, no, I take it back. It will be line 4, line 5. You have to take a pick, because if A bracket M does not equal to K, it will go for one of the branches. So it will either execute line 6 or line 8 as a result, but it doesn't change a single thing because B and E are already of that value. Okay? So, but you'll get stuck. Yep. Yep. Okay? Go ahead.
I was just wondering, how would you, if it was stuck, how would you end it?
You cannot end it. In your trace, we will have to indicate that this algorithm is going to be stuck in an infinite loop.
How would you indicate that? Right.
How do you indicate it? Okay, so you just write down, on the piece of paper, you just say that, this algorithm is stuck in a loop, and you just have to briefly explain why you think it is going to be stuck in a loop. Yeah. So I think that's what you're asking. Yeah. But how can you tell it is stuck in a loop? You go through one iteration, and none of the values has changed since the previous iteration. If that happens, that means whatever was true before is still going to be true, and because none of the values are changing, the next iteration is going to be the same. So that's how you can detect that it is a condition of an infinite loop. But until you see the same repeating pattern, you cannot really come to that conclusion. Okay? Any other questions? Now the exam is on Wednesday, which means next Monday is the last class meeting where you can ask questions related to the exam itself. So my suggestion is to kind of study over the weekend and make sure that you kind of collect all your questions. So on Monday, we can talk about the questions that you guys have. Question?
Can we do some subroutine examples on Monday?
Yeah, we can do that. It's also the due date of your homework assignment, which is perfect.
Sure.
Yeah, which is basically why I schedule the homework assignment to be due on Monday.
Okay.
All right, so I think that's the end of today's lecture. Yep, go ahead.
Just say, after 11, it's just post. If you get a if it's not stuck in there, you can just hit to 11. And
Right, after 11 is post. Yep. All right. So I'll upload the video later today.